So we're going to have a go at this question that asks us to show that x is a rational number. So x is equal to the root of 3 plus 2 root 2 minus the root of 3 minus 2 root 2. And to show that it's a rational number, we have to be able to express it as p over q, where p and q are both integers. So the way we're going to show that x is a rational number is we are going to square both sides. That's the hint given to us in the question. So we're going to find x squared first of all. And then when we have x squared, we can get the square root of that to find x and show that x is a rational number. So we're going to start with the equation we were given. X is equal to the root of 3 plus 2 root 2 minus the root of 3 minus 2 root 2. I'm going to square both sides to get x squared. So x squared is equal to, and then I'm going to have a bracket with the root of 3 plus 2 root 2 minus the root of 3 minus 2 root 2. And that's all going to be squared. And be careful not to just square the first term and square the last term. We need to square the whole right hand side. So on the left we have x squared, and then on the right hand side I'm going to use a rule to square a bracket with two terms. And the rule is I square the first, a squared, I square the last, b squared, and then twice the product. So a times b is ab times 2 is plus 2ab. And so that's the rule I'm going to use to square out this bracket. So square the first. When you square a square root, you get rid of the square root. So we're left with 3 plus 2 root 2. I'm going to square the last. So when I square the root of 3 minus 2 root 2, I'm left with 3 minus 2 root 2. And then twice the product. So the product is what we get when we multiply the two terms. And then we're going to times it by 2. So it's minus 2 on the root of 3 plus 2 root 2 on the root of 3 minus 2 root 2. Okay, so let's give ourselves a bit of space here. So we are now going to simplify this. So I can see that I have a 3 plus a 3, which gives me a 6. I can see that the 2 root 2 minus the 2 root 2 give us 0. And then to join these surds, or to simplify this part of the equation, I'm going to use the rule that the root of a multiplied by the root of b is equal to the root of ab. So I'm going to create one surd, and I'm going to leave the minus 2 out in front, and I'm going to join these together by multiplying what's underneath the surds. So 3 plus 2 root 2 times 3 minus 2 root 2. Okay, so on the next line I have that that's equal to 6 minus 2 by, and then underneath the surd I have 3 by 3 is 9. 3 times minus 2 root 2 is minus 6 root 2. Plus 2 root 2 times 3 is plus 6 root 2. And then 2 root 2 times minus 2 root 2, we might just do that over here. So we have 2 root 2 times minus 2 root 2. So 2 by minus 2 is minus 4. Root 2 by root 2 is 2. And minus 4 by 2 is minus 8. And so at the end here we have minus 8. Okay, so x squared is equal to 6 minus 2 on... Now, we have, underneath the square root sign, a minus 6 root 2 and a plus 6 root 2, so they give us 0. And then we have 9 minus 8, which is the number 1. On the next line, we have x squared is equal to 6 minus 2 by... The root of 1 is just 1. So x squared is equal to 6 minus 2. X squared is equal to 4. So ordinarily, if x squared was equal to 4, we would say that x is equal to plus or minus 2. But in this case, I can clearly see that this surd on the left is larger than this surd on the right, because this one has a plus and this one has a minus. So if the first term is bigger than the second term, well then x must be a positive number, and so x must be 2 in this case. And so we discount the value minus 2. Now, either way, it would have made a difference to the final answer. Our job was to show that it's a rational number. We found out that x equals 2. So x equals 2 can be written as 2 over 1. 2 and 1 are integers, and so we've shown that x is indeed a rational number.